Hello everyone, this is Todd from PingCap Education. As recording voice takes too much time, this time I am using artificial intelligence to greet you. It is also very helpful in situations where recording voice at home is challenging. And this saves me at least 4 hours, which can be used to make more demonstrations. Thank you for your understanding. Today's demonstration will showcase how TiDB has the ability to horizontally scale out and in, automatically, and seamlessly, without any impact on the database client application. Automatic scaling offers numerous benefits such as the ability to handle sudden workloads and reduce costs. TiDB has been designed to be cloud native and is highly compatible with automatic horizontal scaling on different cloud platforms. I devoted an entire day to developing a simple, from-scratch solution for this demonstration. Although it is based on AWS, the idea is applicable to all public cloud options. The diagram on the slide depicts a simplified architecture of the solution, with each component of TiDB contained within its own EC2 autoscaling group. This enables each component to independently adopt the most applicable configuration, such as EC2 instance type, and EBS family, etc. etc. CloudWatch and Autoscaling Group are responsible for automatically managing resource monitoring and autoscaling policies for EC2 instances. The Event Listener program that was created in-house has the capability to trigger the TiUp utility, which allows for automatic management and scaling of different components present in the TiDB cluster. A network load balancer is utilized at the front end to mitigate the interference of the SQL layer, specifically the TiDB server's horizontal scaling operations, on the clients. The SQL layer's presence, which in turn, decoupling the TiKV server's horizontal scaling operations from reaching the client. As a result, the automatic scalability of TiDB will not disrupt client applications. However, when working with the SQL layer's scalability, especially for autoscale and client applications must at least have the simplest connection or transaction retry mechanism, which is a fundamental prerequisite for database application development. To simplify it, PingCap offers a session manager component called TiProxy, which helps to smoothly migrate client sessions during autoscaling. This can eliminate the need for clients to handle connection and transaction retries, saving time and effort. Additionally, TiProxy is readily available in TiDB Cloud without any extra configuration. Those topics will be further elaborated in another session titled Achieving Zero Downtime During Online Upgrades. Without further ado, this plan relies on several AWS services such as Autoscaling Group, CloudWatch, Event Bridge, Lambda, Simple Queue Service, and Network Load Balancer. All of these services are fundamental and backed by AWS support and are competitively priced. At the beginning, the cluster comprises 3 TiKV nodes and 2 TiDB nodes. During the demo, I will run a sample client program with 4 threads that will continuously insert data into our TiDB to represent our dummy workload. There is also a terminal window, specifically for querying the data that has been inserted into the TiDB. There are 2 fields in the result that indicate the number of successful insert events processed by each SQL layer TiDB server. Here is a problem: we should have 2 SQL layer TiDB servers. Why does it seem that only one is in service? This is the result of load balancing, which I don't need to control specifically. There will be 2 TiDB servers in the results eventually. We can take this opportunity to look at the situation of the load balancer. The load balancer recognizes 2 registered TiDB servers. Return to the previous terminal window, and sure enough, both of our TiDB servers have appeared. Next, let's activate the event listener in the foreground. It is important to note that its purpose is to receive auto-scaling events at the EC2 instance level, and utilize the TiUp utility to perform tasks such as adding, removing, or modifying components in the cluster, based on the type of event. By putting it in the foreground, we can observe its actions more clearly. It's a simple Python program, which also ensures its own high availability through an autoscaling group. Currently, there is no EC2 instance autoscaling event occurring, so the output is empty. The first layer to consider is the stateless SQL layer. I put it in the autoscaling group named TiDB, which enables automatic scaling of the TiDB server. I am confident that you are already aware of TiDB's ability to scale. But, how to do it automatically? In fact, any type of metric alarm within your reach can trigger it. In this solution, I use the simplest metric to do that: the average CPU utilization. I use the average CPU utilization as the triggering alarm for automatic scaling of EC2 instances. The intention here is that I expect the average CPU utilization to remain at around 30%. In case it exceeds this threshold for a sustained period, it should trigger the addition of new EC2 instance, which is scaling out. On the other hand, if it drops below the threshold of 30%, the number of EC2 instances should be decreased over time, which is scaling in. Of course, as the best practice, and in order to ensure the stability of the client application, the strategy for scale-out should be aggressive, while the strategy for scale-in should be more conservative. Additionally, there should be a cooling time between two consecutive automatic scaling actions, to give the auto-scaling result sufficient buffer to take effect. Otherwise, blindly scaling out will make you spend a lot of money unnecessarily, right? Please note that CloudWatch service here is only responsible for the auto-scaling of EC2 instances. You will need our event listener to handle the auto-scaling of cluster components. Next, let's trigger the auto-scaling out of the SQL layer. Look at the right corner. This is the current average CPU utilization of the SQL layer. It is very low. Now, I am running a script that to hog the CPU of the existing TiDB servers in the SQL layer. Meanwhile, bring up the terminal window of our event listener program. We expect the following results. First, CPU utilization will increase, and for a period of time, the utilization will remain high, triggering the auto-scaling group to scale out new EC2 instances. My settings require the utilization surge to remain for at least several minutes before the scaling out action, so let me fast forward a bit. At this point, note that our example program is still running normally. Keep fast forwarding. Have you noticed the change in CPU utilization on the far right? It has already exceeded 30%. The listener received an event indicating that the SQL layer has been scaled out. New EC2 instance is available, which means that at least one new virtual machine has been launched. Next, the listener will use TiUp utility to prepare this new EC2 instance as a new TiDB server, and add it to the SQL layer in the TiDB cluster. Automatically provision it, modify its system parameters. Automatically join the TiDB cluster. Success. By observing the specific changes of the autoscaling group, we found out that in order to alleviate the CPU pressure on the existing nodes, 2 new EC2 instances were automatically added. So now there should be 4 TiDB servers in total. It can also be confirmed from the status of the cluster. Again, our example program is still running normally. From the load balancer perspective, it can be seen that the newly added TiDB servers have not passed the health check yet, but it will be soon. Look, now all the TiDB server is up and running, and in service. After the automatic scale out on the SQL layer, let's take a look at its automatic scale in, and TiKV's automatic scale out. It's not about saying that these two components must undergo scale in and scale out at the same time. I'm just trying to express that there is no relationship between the horizontal scalability of the SQL layer and the horizontal scalability of TiKV. They are decoupled from each other. In the real-world environment, TiDB is responsible for the computing layer, and TiKV is responsible for the storage layer, which can be scaled in or out as needed, independently. If you are not familiar with this concept, it is recommended that you learn more from the courses provided by PingCap Education. Next, I will relieve the pressure on the TiDB server's CPU. Next, hog the TiKV server's CPU. By the way, the auto-scaling strategy configured at the TiKV layer also uses the threshold of 30%. Therefore, the combined changes will result that the SQL layer will automatically scale in, while the TiKV layer will automatically scale out. Release CPU pressure of the SQL layer. We can see that the CPU pressure of the SQL layer has been released. However, do you remember that we should be conservative when scaling in? I followed this strategy when build up the auto-scaling policy. That's why it will take a few more minutes for the scaling in to occur. While waiting for SQL layer to scale in, let's give TiKV nodes some workload to consume the CPU. Observe the CPU utilization of TiKV autoscaling group. Reminder, the event listener is showing below. We can see that the SQL layer has automatically scaled in. This is as expected. Automatically remove the TiDB server from the cluster. Currently there are 3 TiDB servers. Succeeded. The SQL layer has triggered an automatic scale in again. The autoscaling policy considers that 3 TiDB servers are still too many. The number of TiDB servers will become 2. Our example workload still runs smoothly. What's happening here? Let me take a look. Pretty good. This is the automatic scale out of TiKV, and that we've been waiting for. The number of TiKV nodes has now become 5. And the number of TiDB nodes has become 2. The example workload is still running smoothly. Finally, let's release the CPU hoggers of the TiKV layer, triggering its automatic scale in. There are some repeated operations, let's fast forward. Stop consuming CPU. Now, the TiKV layer has 5 nodes. Fast forward a bit and wait for the automatic scale in to happen. I would like to remind you again that I have set the TiKV scale in strategy to be quite conservative, and you should also do the same in your real-world environment. After all, it is a storage layer, and its automatic scaling conditions should not only be judged by CPU usage. Automatic scale-in has occurred. There are only 3 TiKV nodes left. From 5. decreased to 3. Our sample workload, representing your business, is still running without any impact. Let's review and see what exactly happened throughout the demonstration. In this auto-scaling solution, when the SQL layer is overloaded, the TiDB nodes in the TiDB layer automatically increase from 2 to 4. After the surge disappears, they decrease back from 4 to 2. When the storage layer is overloaded, the TiKV nodes in the TiKV layer automatically increase from 3 to 5. After the surge disappears, they decrease back from 5 to 3. During the entire process, the application is up and running. However, my sample application is extreme lightweighted. In real-world scenarios, TiDB server is stateless and easy to scale out and scale in, while the TiKV server needs to redistribute the data, so it might impact the QPS. By using TiDB, even on the crucial database layer, you can spend money where it matters and save money where it counts, while keeping your business up and running smoothly. This strength is far superior to MySQL or Amazon Aurora. If you are interested in the specifics of how this solution is built, I can open another topic to discuss it in detail. However, today's focus is on the demonstration of auto-scaling capabilities. By the way, I will share all the scripts, programs and the CloudFormation used in this demo on GitHub. Welcome to contribute together and help the education team to improve. If you opt for TiDB Cloud Serverless, you can readily access all the aforementioned benefits without having to concern yourself with implementing automatic scaling. They are out-of-box fully managed. If there are any fundamental concepts, which are not very clear to you, such as the difference between TiDB and TiDB server, TiKV, SQL layer, storage layer, stateless and stateful, etc., you might consider going to the PingCap training and certification site. Enroll and learn the free self-paced introduction to TiDB course first. Thank you so much. See you in the next demo.